Now, in the previous video, you may have noticed that I did not try to generalize the solution when the right-hand side is a power of e. And the reason is that there is a tricky part that we have to worry about. And I'll try to illustrate that with the following example. So let's try to find a particular solution to the differential equation y double prime plus 5y prime plus 6y equals e to the power negative 2t. So what we did in example 1, or sorry, in example 2, we tried to solve this by setting yp of t equal to e to the power negative 2t with a constant in front. And that worked really well last time, so let's see what happens here. Yp prime of t is then negative 2a e to the power negative 2t, and yp double prime of t is equal to 4a e to the power negative 2t. Our differential equation has to satisfy yp double prime plus 5yp prime plus 6yp equals e to the power negative 2t. Okay, so let's take yp double prime. That is 4a e to the power negative 2t. And then we have plus 5 times yp prime, which is negative 2a e to the power negative 2t. And then we have plus 6 times yp. And that's just a e to the power negative 2t. And all of that has to equal e to the power negative 2t. So let's simplify the left-hand side. We get 4a e to the power negative 2t. Then we have negative 10a e to the power negative 2t. And then we have plus 6a e to the power negative 2t. And that equals e to the power negative 2t. But what we notice now on the left-hand side, we have 4a plus 6a is 10a, and a minus 10a. So the left-hand side simplifies to 0, and that has to equal e to the power negative 2t. Again, this is a constant that has to equal this for every value of t. That's a contradiction. So what worked so well last time does not work right now. So why is that? So let's ask ourselves, why does this not work? Well, it has to do with the auxiliary equation for this differential equation. So the auxiliary equation for our differential equation looks as follows. It's r squared plus 5r plus 6 equals e to the power negative 2t. Equals 0. the auxiliary equation equals 0. We factor that. We can do r plus 2 times r plus 3 equals 0. And so r plus 2 equals 0, and r plus 3 equals 0. So r equals negative 2, or r equals negative 3. And that means that the general solution, right? So I should make this a little bit clearer that we looked at the auxiliary equation for the homogeneous differential equation, right? I set that equal for now, and then look at the auxiliary equation. So it means that the general solution to our differential equation is c1 e to the power negative 2t plus c2 e to the power negative 3t. So now here's the problem. This part we tried as a particular solution, but the problem here is that this solves this. Where the right-hand side is 0 and not e to the power negative 2t. So the problem is that the solution to the homogeneous differential equation already has an e to the power negative 2t. And so when it shows up on the right, our first try does not work. So let's try something else. And this try basically comes from what we've seen before with a repeated root. And when you have a repeated real root, you had one part of the solution was, let's say, e to the power 2t, and then the second part was we introduced a factor of t. So we're going to try that here as well. So I'm going to do yp of t is a times t, and then e to the power negative 2t. So that's yp of t. Now yp prime of t, we have to do a little bit more work because we're going to have to use a product rule. So derivative of at is a times e to the power negative 2t, and then derivative, or it's a times t times derivative of e to the power negative 2t, which is e to the power negative 2t, and then that negative 2 comes in, moves into the front. So that's a product rule. And then yp double prime of t, we're going to need a product rule for this part. The first part is negative 2a e to the power negative 2t, and then a product rule for the second part, we get negative 2a e to the power negative 2t, and then the last part is plus 4at e to the power negative 2t. So product rule, and then another product rule. Now, this is going to get a little bit messy, but if we keep track of our coefficients, we should be able to take this to the finish line. So our differential equation that we need to satisfy is yp double prime plus 5y prime plus 6y p, and this yp prime, and that has to equal e to the power negative 2t. Okay, so we start with the most complicated looking one. So that's negative 2a e to the power negative 2t minus 2a e to the power negative 2t plus 4at e to the power negative 2t. It's the first part. Then we have to multiply 5 times y prime. And so that is going to be a e to the power negative 2t minus 2at e to the power negative 2t. And then finally, the last part, right, the 6yp, it's 6 times, and then we have at e to the power negative 2t. And then that has to equal e to the power negative 2t. Okay, so we need to combine like terms. So let's take a look at all the parts that have a t in it, the factor t. So t e to the power negative 2t. So the first part is we have 4a, and then plus 5 times negative 2a. So that gives us negative 10a. And then we have a 6a e to the power negative 2t. So we're going to add 6a to that. And I think you're seeing what's happening there. We have that t e to the power negative 2t. And what you notice here is that this is already 0, right? 4a minus 10a plus 6a, that is already 0. So that whole term will disappear. Okay, so now we can take a look at what about just the e to the power negative 2t? What do we have there? So then we have this term, we have this term, and then we have this term right here, right? And so that gives me negative 2a minus 2a, and then plus 5a. Right? So this is plus, and then I have e to the power negative 2t. So this whole thing disappears. And here on the left, I just have negative 4a plus 5a. So that becomes just a times e to the power negative 2t, and that equals e to the power negative 2t. Now, what I could do is bring this to the other side, and let me do that. A minus 1 times e to the power negative 2t equals 0. And again, because this has a t and this does not, we then see that a minus 1 has to equal 0, and that means a equals 0. Now, I hesitated doing that, and the reason is, if you see this, you see on the left you have e to the power negative 2t, on the right you have e to the power negative 2t. It needs to be the same for any t value. Well, since these two t functions are identical, that means that the coefficients have to be identical as well. So you could directly see that a equals 1. If that is a little bit too hard to see, don't hesitate to keep doing it the way we've been doing it before. So a equals 1. So now our total solution to our particular solution to the differential equation is yp of t equals a times t e to the power negative 2t. And so let me put that t there, and you don't have to write down a 1 in front of it, but just showing you where that comes from. And that is our total solution, our particular solution to the differential equation. Now, in the next video, we'll generalize all of our findings in a theorem.